All right, cool. All right, so today we're going to talk about object-oriented programming. So first of all, who is at least maybe familiar with like maybe heard object-oriented programming before, or maybe they had it in school, maybe you just heard it at least once time. Has anyone had any familiarity with that? Okay, I see Bonnie had, see Griffin kind of go there. I think Joshua probably has since he has a computer science background.
Yeah, I was gonna say you can't see me raising my hand, but experience.
Okay, cool. So, and then I'm guessing Adam and Yasmin, you guys maybe not so much at all? Okay, so, and that's fine. That's perfectly fine. So you can always go to the people who feel more comfortable with it and stuff like that, help each other out in Slack. But we're gonna dive right into it. So I'm gonna share my screen real quick. There we go. I think this is it. Okay, so the first thing, so hopefully you guys can all see my screen right here with the Google Drive, right? Mm-hmm. So we're gonna be sharing this, resources. Turns out Eli actually put these together, so we might add more to it. But just know that this drive carries for both today's lecture, today's study group, and next week's study group for section 6 in section 7, just because basically section 7 is a continuation of object-oriented programming. So I just kind of want to show you a little bit of the cheat sheet so you don't get too freaked out when you see it. There's a lot of information on the cheat sheets, and a lot of object-oriented programming is about structure and how we build things. So just kind of know that don't feel like you have to have it memorized. This is what a cheat sheet is for. Is to quickly refer to things. You can see there's more information on here too. And I think this one right here, let's see here. We have a couple Jupyter notebooks that you guys can download, check it out. Of course, this is in supplement to the curriculum itself. So the key would be, I would say, start with the curriculum, go through it, and then maybe as you go through it, or maybe as you finish the curriculum, go back to these resources and kind of like see emphasis, maybe revisit and everything like that. But one thing that was put together is Eli put together this Google Doc, and these are some great resources that he found, YouTube videos that could help you go through. Again, there's quite a lot here. Don't feel like you have to go through all of these, by the time you finish section 6, if you need to, you can go back to it, resource it, all these things. But the main thing that you'll want to check out is make sure you understand these parts. So this is like our learning objectives. And I don't know, we've kind of seen this a few times now, but your learning objectives are really saying like, what is the point of you learning this? Like, what should you feel like you take away from section 6 and section 7? So the main thing is identifying where object-oriented sits in data science process. Why are we using object-oriented programming in data science? That's the kind of idea. You should be able to articulate the reasons why you would use object-oriented programming. And that's a big thing that in an interview for data science is say, well, okay, once you're familiar with object-oriented, and they say, what's the whole point of it? Like, what is the why, the what, and the how? And one of the big reasons, we'll kind of talk about the reason why, but basically object-oriented programming is so common. And as a data scientist, you have to be a programmer, you have to be a software developer, at least in some part, that it's just likely to come up, and you're going to be interacting with other software developers too, making, putting things out to, what's it called, deploying, full software, okay? But kind of go through this part, make sure, if you were saying, am I learning everything I'm supposed to? This will kind of give you a nice checklist of saying, okay, yeah, I got this. Okay, I got this, good. And then of course, there's some more resources on the bottom here. And again, these things might be added in, more resources either on this sheet or in this drive right here. There's also a great slideshow that kind of like what Eli had put together with Google Slides that kind of goes through object-oriented. Just know that it's kind of sparse, so don't feel like you're going to completely learn these things just by looking at the slide. So it's important, again, you go through the curriculum and really understand it. And then of course you have questions, ask. That'd probably be the very first thing, since you guys are all one big community on Slack. You guys can ask questions and see stuff out. You can use these resources. You can of course research stuff, and that's just kind of like a way to go through it. Again, you guys kind of know this stuff. Cool. All right, so I'm gonna dive right into kind of similar notebook, and you guys can see that okay? Okay, is that right? Cool. I know last time it was a little small. So I kind of broke this up. Know that we're not going to go through this whole thing on object-oriented programming. because some of this notebook will expand into section 7, which will be next week. So, but the first thing I want to talk about is basically what is object-oriented programming, okay? So the first thing you should know is, or you should think about, is like, when you write a program, how are programs actually written, all right? So one kind of big takeaway, like this is more computer science based, but basically we can go deeper and say, oh, assembly language or binary, like you can think zeros and ones, but mostly programming languages, at least that we use today, tend to be in these 3 different categories. A procedural language, which is basically just a bunch of code and you're reading it through. You essentially just go from the top down, going all the way through. And the really old programming languages would have things like goto. So for example, Fortran would have this still, where if you see like, what's it called? It's like goto, like this statement, you'll see that sometimes referenced back in the day. And that's because you basically would continue forward, your program would run basically top down, like when we run Python, top down. And if you needed to go back to something, you would actually use a goto and it would go to that spot and run those parts. So this is a procedural programming. And languages that include that were like C, Lisp, like I said, Fortran. Fortran's actually a really old language, but it's used a lot in scientific scientific programming. So just know that there are people who still write in Fortran. Sometimes people get confused or are surprised by that. The next one is functional programming languages. Now, when we get into functional and object-oriented, OOP, just know that most languages are not only this one or only object-oriented. Usually they can do a little bit of both. Some pure functional programming languages are things like Haskell, which is more used for research, and OCaml, which is there's other use cases, more enterprise stuff. But just know functional programming has their own little weird quirks if you do a pure one, and it tends to be more mathematical based. It's based around functions and passing functions off to each other. And again, if this was a computer science course, we would talk about all the differences and why this is. Like, you can take a whole semester easily on functional programming languages and say, what are the differences and the different styles? But just know that this tends to be much more difficult to program. They do have advantages. For example, they have something, they don't have side effects if you're a pure functional programming, which means you're less likely to get bugs, but it takes you probably at least 3 times as long to write the same program. So that's one of the reasons why it's not as popular right now. And the most popular is really object-oriented programming, which includes Java, Python does object orientation, C++, JavaScript. These all basically can do object-oriented programming. JavaScript and even Python at some level can do functional programming, but it tends to be seen as more object-oriented, okay? So this kind of goes into saying, okay, well, cool. That's nice. Like, they're different programming philosophies, but what is OOP? So object-oriented programming basically uses the concepts of objects and classes. And the way I kind of think about this is that all programming languages at some level eventually go into machine code, essentially binary. Like, they're just telling the computer what to do, but you're writing it in English, or, it doesn't have to be English, but you're writing in some language that's a little easier to read as a person, right? Compared to coding in zeros and ones, or if you're really, they actually did this as hex code, where it's like they're basically looking at memory space, and it was a pain in the butt. Like, it was a lot of work to actually get through that. So the idea here is that we can use concepts of objects and classes to help organize our programming philosophy. And a lot of it ends up being, what's it called? Like a philosophy, and kind of like, I see it like an analogy to like the real world. Like, the reason why we have this thing called objects is because we have real things in the real world that are actual objects. And it kind of helps us organize our thoughts and be able to proceed with that. So what we mean by objects and classes, I like to think of it as a mold, but the curriculum talks about it as a blueprint. And so you can kind of think is that when you define a class, okay, basically you're creating a blueprint of this thing that you'll create an object out of. Or I like to think of it as a mold. So like, you take your mold and you can basically create, we call it instantiate, but basically we create new objects. So for example, we might have a basic blueprint or basic mold of a car, and you can create an object with maybe slightly different variations. For example, a van or an Audi or a sports car. And similarly, you can kind of see a little more generic here. We have a blueprint or a mold of a car. In this case, all cars that we're going to create from this class, they all have wheels. So that's why you can see they all look very similar, but they might have different attributes. Okay, it might be a little different. So again, you can kind of think of, what's it called? You can think of classes and objects like pretty much anything, like basically nouns. So like, for example, you'll have a person, like you might have a class of person, like, right? Like the class is person, but of course, all of you guys are not the same. You guys all have different attributes that make you all different, okay? Some people, might have very similar attributes. For example, twins might have many physical attributes that are exactly the same, but of course they're not exactly the same. They might, first of all, they're not the same person, right? If you poke a twin, the other twin shouldn't feel it, right? I mean, hopefully, who knows? Like, I guess like they're psychic or something like crazy like that, right? But for the most part, if you poke someone, it doesn't hurt someone else, okay? It's not the same person. And that's kind of like what objects are. We have very related things, but are not exactly the same. Hey, Olivia. Okay, so that kind of gives us what the idea of what attributes are for an object, okay? Any questions on that? So, okay. So thumbs up if you're feeling like, okay, I think I catch you right now. Class is basically a mold or a blueprint, cool. Objects are basically created from that mold or created from that blueprint. I like to say it's a good metaphor, but it's not exact. We'll see where the metaphor kind of breaks down, but it helps us give us an idea of what we're doing, okay? So this leads us into the why of object-oriented programming. So kind of like what I mentioned before, like almost everyone is doing object-oriented programming. If you look at like this, I found this online basically, but this is pretty much true for 2018 for every other metric, depending on, who's doing it. The most popular languages, Java, JavaScript, C#, Python, C++, PHP, Ruby, Go. Those are all object-oriented programming languages, or at least you can do object-oriented programming in there, and most people do. It's a great way to basically quickly organize a code base. And you guys probably haven't realized it, but even in Python, we are using object-oriented programming. When you guys import something like Pandas, you're actually importing a class and you're getting something like a data frame or a series or other attributes. So as we kind of go through this, you'll probably recognize like, oh wait, we kind of did something similar. You just probably didn't realize it. And it's just a way to organize your code, right? And again, it's just a method to organize your analogy. Kind of put no pun intended here because we'll later see that a method is actually a very specific thing in object-oriented programming. But basically, like I said, objects are things. Like you can think anything that's a noun. It can be a physical item. It can be an activity. It can be a concept. Basically, you can kind of organize everything as a thing. And because of that, that allows you to kind of create really abstract stuff with object-oriented programming. Okay, and again, it's very flexible. We'll see that we can take someone's object or you create your own object, and then basically we'll do something called like inheritance. And basically you can create an object from another, or not object, create a class from another class, and you'll get those properties from the original class. So it's actually really flexible to be able to extend it out to basically make specific details of it, what's it called? Specific details to an object. So like you can create this object and then modify it. So like you can imagine if you make your mold, I like to imagine like if you pour like plastic into this mold and you make this toy, you can maybe paint the toy differently. Maybe you can add some, extra little features on there after you put it in the mold. But like the nice thing is kind of like how we do molds, in like real life, is that you can make things very quickly this way that are exactly the same and then modify it as you need to. So that's one of the reasons why object-oriented programming has been really popular and probably will be popular for a long time. Again, I can't, I'm going to say that I'm not going to know exactly when this was created, but basically back in C++, which has been around for quite some time now, that's when we actually got object-oriented programming as like a real, I should say C++, part of the reason why it was invented from C was because to more easily do object-oriented programming. So it's been around for a while and it's really useful. Okay, so cool. Any questions, any comments? Those of you guys who've had computer science background or at least exposure to this, if I say something, slightly wrong, or if you want to add a comment in there, feel free to interrupt me. Okay, cool. So this kind of leads us to like, okay, cool. This is object-oriented programming. We kind of get the whole why of this part, but now we got to say, okay, we want to do something with it. So we actually create something called a class, right? And there's basically two parts of object-oriented programming, which are basically your classes, your molds, your blueprints, and then your instances, which are really just the objects. So we'll talk about doing it, making instantiation of a class to make your object. So again, you should think of like your class as your blueprint or mold. And your instance, which is really your object, is made from the mold. But remember that it's an individual and separate from all the others of the same mold. So if you imagine, like this is just in real life, right? If you take a mold and you pour plastic in there, and then you take the same mold and pour a different plastic in there, you're going to create two different toys. They might be very similar to each other, but they're literally not the same thing, right? So that's an important kind of distinction to have. So we can go right into the code a little bit, and I won't dwell a whole lot on the code just because you're going to see a whole bunch of it and go into more details. I kind of just want you to see this code to first of all see a way of creating a class. So you're kind of like, okay, I see this before, and then actually see how you might actually program with it and kind of see how you can play with this. So here's our code right here, and I made a class, and you guys can read this okay? Not too small or anything? Cool. All right, so I made this class called a robot. And you'll notice that I just do a pass right here. That's just basically, have you guys have seen pass now in Python, right? Nod your head if you've seen it. Cool, all right. And so if you haven't realized what pass is, pass basically is essentially like a little space. Like, oh, there's some stuff here, but we're gonna just ignore it for now. So this way we can make basically an empty class. So Python knows, hey, we're gonna make a class, but we're not gonna do anything with it. So you can think of this robot thing. We haven't really specified any special things. It's kind of like a blank template. There's nothing special about this, okay? So I make this class right here, and you'll notice that nothing happens. In fact, you've kind of noticed what this might look like similar to you guys, something you've seen in Python. I'm looking for a special kind of thing that we've seen before. It starts with an F.
Function.
Function, good, good. Okay, so if you remember, if you wrote a function, right, you would see it really similar as define, maybe like, let's say robot, right? You might take a parameter, you might not, right? And then you might do something like, oh, return, you know, like return 1 or something like that. And that would be our function, right? So you can see it's very similarly created in the same way a function is. Okay, so kind of there's no the difference right there. But we have our class, our robot, and now I'm going to instantiate a robot. So I'm using the robot class. That's what this is right here. I'm using the robot class to create something called my robot. Okay. And then you'll also notice that I do my robot.name. I'm giving basically this robot, this object, this instantiation, some properties. So in this case, I have the property name, and that's what that dot means. It's like, okay, this is a property name of my robot. This is the property height of my robot. In this case, I gave the name Wally, and I gave it a height of 100 centimeters. I just put 100, but I'm going to imply that it's centimeters, but it could have been whatever I wanted. Okay. And the same thing happens. I made a second thing called your robot. And see, I instantiated it with robot, kind of similar thing. And I made your robot.name, Rob, height 200. So if I run this now, I now created life. I created these objects. I created these robots, right? So now these robots have properties. So I can print out saying my robot.name. And what do you think that would give us if we did robot.name?
Wally.
Wally, right? Pretty simple, right? And same thing, my robot.height, 100. Again, this should look actually pretty similar. We've done pretty much like this, you know, with pandas and everything like that. And that's because we've been using objects. We just haven't known it. So if I do this now, you actually see that I get Wally, 100, which would be its height, and Rob, 200, which is his height, okay? And now what happens if I do print my robot.purpose? So anyone got a guess what will happen when I do this?
Error.
Error? Anyone else got an idea? I'm not saying it's wrong. Okay, cool. So yeah, I would have accepted, like, you know, it's one of those things like, oh, it could have maybe gave like nothing, or, you know, maybe it's blank or something like that. But it turns out Yasmin is right. It does give an error. And you'll see it gives us very specific error. It says attribute error. And it gives all this chunk and tells me exactly where this happened. It happened on print my robot.purpose. And it says robot object has no attribute purpose. We never defined it up here. You can see we gave it .name, we gave it .height, but we never gave my robot a purpose. Okay, cool. Any questions on this so far? And hopefully this feels pretty good. It's like, okay, like the only difference we did was we made a class this time. We made instantiation, but you probably have seen this dot name, dot height, assigning those dot name, dot heights to different things. So that should feel pretty obvious. And then of course, dot purpose doesn't exist. So that's why it gave us an error, right? So that's kind of cool, but like we can make it a little bit better. We can make a better blueprint. So in this case, you can see a very similar thing where we have class robot, and all our robots should love humans, right? So we give it the purpose to love humans, okay? That way we don't have any robot uprising or anything like that. So the idea here is that we have this mold. Now, every time I make a robot out of my mold, out of my class, I instantiate a new robot, it'll have the variable, this attribute of purpose, and its purpose will be to love humans. So I do something very similar. If you notice, it's exactly the same code as I did before. My robot equals robot, Wally, 100, and same thing for your robot, for Rob, and 200 centimeters. So you notice I never gave it the name purpose, right? And so I run this. So now I have my robot, which is Wally and Rob. So I say, okay, I'm going to ask it, what is your purpose? That's just for fun, right? And then I'm going to print out my robot.purpose, which again, before it gave us an error. So as you guys probably guess, when I print this out, if I run this, I see that it actually gives out to love humans, right? So we gave it that property. It gave, we had that in the blueprint, so it's easy to do, right? So any questions on that so far? Again, pretty straightforward, hopefully. Feels pretty obvious, okay? Now you'll notice I created a rogue robot here, this example. And so I created a new thing called an evil robot, a little foreshadowing there. I use the same template, this robot thing, right? So it should be, its purpose should be to love humans, right? And I gave it the name Bender, and then I changed actually evil.purpose, or sorry, evil robot, which is again, it's just the object. And I gave it, I changed the dot purpose, which we had defined before to love all humans, or to love humans, and I said I changed it to kill all humans, all right? Evil robot. And so now obviously when I print out your name, or I ask basically just print out, what is your name and purpose? And I'm giving this part right here, and I'm printing out what's the robot's name, which should be just Bender, since we defined it up here. And we can see my purpose is, and it'll give me its purpose. So if we run this now, we'll actually see that its purpose has changed. His name is Bender, and his purpose is to kill all humans, which was not part of the blueprint. And remember, is that the blueprint's completely stays exactly the same, right? We haven't changed the blueprint. All we did was change that one specific robot and its purpose. Cool. Any questions on this so far? Okay. Hope give a thumbs up if you're feeling like, oh yeah, this seems pretty straightforward, pretty easy. Cool. All right. Hopefully that feels good. All right. So again, I'm going to keep using these words, instantiating an object. Okay. So, excuse me. Actually, I have to remind myself what we did here. Okay. So we can kind of go back, say, okay, cool. We have this robot, which we're going to use this class up here, right? Its purpose to love all humans. I can give it some properties, name, height, just like before. I'm just double checking that I have that. And I can actually start doing some programming. So this is kind of showing that how you can organize your code. You can organize your code so you can use a blueprint, instantiate some objects, and then use those objects for things. So this right here, I'm just going to figure out who's taller. And note that I put a tie defaults to my robot because it just made the code easier like this. But I'm going to find out what the tall robot is. Okay. And so this is a little different. I kind of threw this in here. There's an alternative way you could do this with if and else statements. Have you guys seen this if in one line kind of deal? This might come up a few more times. This happens a lot in Lambda. So I'm kind of going to walk you guys through this since you guys might not have seen this specific way. So I said here, okay, tall robot is equal to. So that means I'm going to assign tall robot to whatever this gives me over here on the right. So let's kind of look at what this is. So I'm just kind of read it out loud, and I think that kind of makes a lot of sense in Python. So I say my robot. So I'm sending my tall bot to my robot if my robot.height, so its height, is greater than or equal to your robot's height. Okay. Otherwise, else, we'll assign it to your robot. Does that make sense? Mm-hmm. And this code right here, this alternative code, is literally the same thing. If I ran this code in purple that I'm highlighting over here, that will literally do the same exact thing as this guy. So sometimes, you know, it's arguable to say, oh, is this a better way to write it? Well, sometimes it's just an easier way to write in one line. So you'll see both of these ways written out. But you can see, depending whose robot is taller, if my robot's taller, or, you know, if they're the same height, it'll be assigned to my robot. If it's not, it's going to be assigned to your robot. Okay. So first of all, what should tall robot be? If you guys recall what we defined up here.
Rob.
It should be Rob, right? It should be your robot, right? And remember, Rob is technically its name, but it's not the object itself, right? So we can actually print out when you say tall bot.name is the tallest bot at tallbot.height. So notice that I didn't have to like say, to go each time saying, oh, do this name, do this height, you know, all that stuff. So if I run this now, we should see that Rob is the tallest robot or bot at 200 centimeters. So you can kind of see how this might be really useful. You can have, for example, I only have 2 properties, its name and its height, but imagine if you had like 10 properties or even 100 or 1,000 different properties and going through that stuff. And instead of going through each individual part, it might be easier to actually define, like basically, I just wanted to compare the heights. And then once I had the heights, I know what robot I want, and I can call all the properties I ever want from that robot. Okay. And again, this is what makes it really flexible and really able to, what's it called? You're able to extend it out further and further. Okay. So any questions on this guy? Okay. Feeling pretty good? Not too bad, right? Okay, cool. So one thing to kind of note is that, again, robots are individuals, or I should say objects are all individuals, okay? So just because you're both people doesn't mean you're the same person. So even though we're all people, we're not literally the same person, right? We share some qualities, but we're not literally the same person. So I have a little example here. So we have my robot and your robot, which we know are different. And so you'll notice I put like, where are you in memory? And if you print this out without specifying some property of it, you'll see this weirdness. And you'll see like main.robot object at a bunch of weird variables, right? Or a bunch of weird stuff. And then the same thing happens at this robot right here. So know that this guy right here corresponds to my robot. In this case, we called it Wally. And your robot here. And what this is representing is actually a memory space. Again, this isn't something you need to know specifically, but note that they're different. And that's because objects actually take up space, memory space, just like real objects do, right? You as a person take up physical space. Does the concept of a person take up any space? No, not really, right? The concept of a person, just a concept of a person. Just like in some ways, like this is, again, not perfect analogy, but a mold or like a blueprint can be essentially really, really small compared to the actual thing, the actual object. And so this is an important part where you'll get issues where you're trying to figure out which one's which. So I'm kind of showing you some differences here. So if you test them out saying, is my robot equal to your robot, or my robot is your robot? And then you also check out my robot equals my robot. So first of all, anyone guess what this should give out? True or false?
False.
False, right? Yeah, okay. It wasn't a trick question, right? It shouldn't be the same, right? And same thing for here too. I'm just showing you that there's also an is part. So you'll sometimes see is because these can actually do different operators on it. And this is a little more advanced, but these don't always give the same answer, is versus equals. So just be aware of that. And then of course, my robot equals my robot should be true, right? It shouldn't be a different person. And we can see, we get false, false. Are you yourself? True. Okay, straightforward. Now here's a little more advanced one. I made a generic robot equals 0. It's a robot. Generic robot 1 equals robot. And I did the same question. Is generic robot 0 equal to generic robot 1? So anyone got to guess if this should give true or false?
True.
Okay, someone says true. Does anyone have a different opinion? So, okay, everyone says true?
I think true for both.
What was that, Josh?
I was saying true for both, I think.
True for both?
I don't remember which operator compares the actual object and which one compares the equality.
Good, good. So, okay. So good. So we're saying, okay, everyone says true then? Thumbs up for true. We run this guy. Generic robot 0, generic robot 1 is, it's false. What? what's going on? Well, remember, every object is its own special individual, its own special little snowflake. In this case, it's special little robot. Okay, generic robot equals 0 was created from this class, this mold, and so was generic robot 1, but they're not the same robot. They have their own hopes and dreams, you know, internally. We haven't told them what their hopes and dreams are yet, but they will have their own hopes and dreams. So they aren't actually the same robot, and we can actually kind of double check this. So if I do print and then generic robot 0, and then similarly, so I got a new keyboard here because my keyboard messed up, so it's a little loud. But you can see here, they have different memory spaces. So that's really what it's comparing. It's, and that's where Joshua was kind of saying like, oh, I'm not sure which one it checks. That's a big difference. It's like, do they check if it's a different memory space? Okay. And in this case, it turns out is and equal, unless we define it differently. It should give us a different stuff. So, okay, so that makes sense. That should hopefully make sense. Even though we made it from the same class, the same mold, they shouldn't be the same robot. Okay. So let's go to on this one. This one's a little more advanced. So this time we're saying same robot equals generic robot 0. Okay. Notice that we didn't do that robot, you know, we didn't instantiate the object. We didn't do robot parentheses. We just said same robot equals generic robot. And I'm going to ask it the same questions. Okay. I'm actually going to take this part out so we can put that here. So we're just gonna ask the same questions. Is generic robot 0 equal to same robot? And same thing for is, just kind of showing you that. I'll let you know, these are supposed to be the same. So anyone got an idea what this will be? Will it give us true or false? You guys got a question now, right? Gave you guys a trick one last time. I see Adam mouthing something. I'm not sure if he's saying it or not. Go ahead, what do you think, Adam?
I'm going to say true and false, but I mean, I was wrong the last one. So. Okay,
so one of them will give true, one of them will go false?
Yeah. I think these both should be true, but we'll see.
Okay, so good. Good. I like that. I'm messing with your guys' mind a little bit now. All right, so if we go ahead and run this, right, we'll see what happens. And we get true. So Adam was right and wrong, but no. It turned out they were both true, right? And that's partly because I didn't define something different. You just, again, know that is and equals doesn't always give the same thing, depending how it's defined. But the reason why these give true is because they are literally the same robot. So for example, I never gave it a name. So for example, if I try to do, let me write a new code. If I do print same robot, oops, I have to spell it right, robot.name, this will give me an error because I never gave it a name, right? It has no name. But now if I give it the same robot.name, 001, I can print out its name, right? So, and I can also give robot.name. So I'm just gonna show you real quick. If I run this part, I gave it a name, I run same robot.name, makes sense, right? So the question is now, I gave same robot its name, will generic robot 0 have a name? So I see Bonnie shaking her head saying no, same robot or generic robot won't have a name. Anyone else got a guess? There's only kind of two different options, right? It either has a name or doesn't. So let's see what happens. It's the same name, okay? So remember, and I kind of gave you a little clue here, is that's the same robot. In this case, when I put same robot equals generic robot equals 0, I'm saying you are the same exact robot, not a twin, not a copy of him, but literally the same robot. Again, this can be a little confusing. You're like, wait, what happened there? But you can kind of see this. One way to quickly check is that if I instead print out its memory space. So I go generic robot 0, we'll see that we'll get the same exact memory right here, okay? And that means that it's literally the same thing. And this is where this can get kind of confusing, but you can almost think of this same robot kind of being like a pointer, like it's pointing at that robot and saying, okay, that is, when I say same robot, I'm talking about generic robot 0. And that's why it's the same exact thing. So whatever I do to same robot, I'm also doing it to generic robot because they are literally the same object. Okay, any questions on that? That one's tough. That one's a little confusing. But I wanted to show you guys that because I've seen, like, I've done this. You guys will guarantee to do this, and you'll find out you did this equal part, and you thought like, oh, I made a copy, like, not the same one, just a copy, and it turns out it's literally the same one. And then you'll find out you'll change like same robot's name, and then you realize, wait, how did this name change? And that's the reason why. Okay, cool. Any questions on that? Okay, cool. So that leads us into a little more advanced thing. Probably won't go through all of it, but I kind of want to give you. So I kind of showed you, it's like, okay, we defined a class, and you can see I did a whole bunch of things just by giving a class just pass, or a class, purpose equal to love. But like, I didn't even do anything with the class yet. I didn't do much to the blueprint. So we can actually get into the blueprint and really change things up to make sure that it has a lot of properties. For example, we have something called methods. We have variables, which you can probably guess what variables are. We also have something called self. And that self is basically going to be a reference to what that object represents. So I kind of started into this since we have a little bit of time. But basically, the first step to know is like, how do objects differ from each other? How do objects vary from each other? They vary with variables. I felt very punny today. I don't know why. But when I was writing this up, I'm like, all right, variables. And that's exactly what you should think. The reason why objects actually differ from each other is really from their variables. Okay. Now, that's not quite true. You can also differ with something we'll call methods. But the main reason why you'll see different objects vary from each other are from its variables. So our good old code. So you can see here, my class here is getting a little more complicated. And you can see I have my class robot, but this time I gave it name equals none, material equals metal, is electric equals true, and number of arms equals 2. And these you can think of as kind of like the default thing that's built into my mold. Whenever I make my new robot, whoever my robot is, she will have this name none, material, metal, is electric, and it'll have 2 arms. Okay, so basically all the molds, no matter if I just poured out the plastic into this mold, into this class, and instantiate a new object, those objects will all have the same properties. So question, kind of quick check. If I made a bunch of, robots with this class, with this mold, if I make robot 1 and I take the mold, robot 2, make a mold, or not make a mold, make an object with the mold, and then robot 3 with the mold, will those 3 robots be equal to each other? Now I saw Bonnie shake her head, and I think I saw people kind of gave a little no. But they shouldn't be the same. They shouldn't be the same because you made it with the same mold, but they are different objects. Okay, so that's kind of, I'm trying to hammer that into you guys. Okay, so I have a new class. I'm making my variable. I'm just calling the variable Wally, or the object Wally. I'm making that robot, and we can actually see with this f string. So I think I've shown you guys f strings before with these, and then these multiple lines with these 3. What's it called? Quotes. But basically, I'm going to say, what's its name? So I get Wally's name, Wally's material, Wally is electric, true or false. Wally's number of arms. So if I print this out, we should see all the default values. And we can see his name is none. We haven't given him a name yet, just from the mold. Metal, true, 2. So now I can actually start changing up my Wally robot. I made him, I instantiated, I basically printed him out on my 3D printer using my class. I instantiated him out, and I'm like, all right, let me go ahead and change up his name. I'm going to change up into Wally. I'm going to change it to, I'm actually going to give him a new attribute too. Notice that I never defined is solar in the class, but I can actually give him a new attribute. Okay, and then we print out the same thing, Wally's name, Wally's material, electric, number of arms, and I'm also going to print out this part since I gave him something new. So if I print this out, you should see all the default values, but this time his name is Wally. So I actually gave him a name. And you can also see he has this new property is solar. Cool. All right. Makes sense on this part right here? Pretty straightforward. Okay, cool. Yeah, and you can see how you can kind of basically, this right here with the dot is solar, you can do this. This tends not to be the best practice, and we'll see why next time when we go into more of the properties and stuff like that, and different things you can do with classes and objects. Usually you'll define all your variables in your class, and then you'll change them, as you kind of go through. But know that this is possible. You can add new attributes to your object. Okay, so let's hear. I'm going to leave some time to let you guys ask questions. But the next thing that we'll talk about next time are functions, or I should say not functions, methods, which you'll find out methods are just functions for an object. Like sometimes I'll slip up and say functions, but really when you say a method, really you're just talking about it's just a function, but it's a function for an object, okay? And then that will actually lead us into what this self is. And self, it basically allows us to I think of it like giving life to it. It's like, oh, you're referencing yourself. So that makes it possible, okay? So cool, but we'll save this for next time, which will get us into more complicated stuff. Know that if you guys actually finish section 6 before we get to the next class, the curriculum will talk about what methods are. They'll talk about self, and it'll even talk about basically getters and setters and deleters. It will talk about that, but we'll review it also on Monday just to make sure you guys got that. And of course, we'll talk about something new called inheritance. And that makes classes really, really powerful in object-oriented programming. One of the reasons why it's so useful. Okay, cool. So got a little about 5 more minutes left. So do you guys have any questions? Anything I went over, either about objects, about classes, could be about the code I wrote. If you're like, wait, I don't understand what that code is. Any questions at all? Comments? Concerns?
Really, really straightforward.
Okay, good. That's good. I hope it feels straightforward because what was that?
I was like, but
Okay, hopefully this feels kind of boring. So you're like, oh, this seems easy.
Isn't that kind of obvious?
Okay, good. That's kind of my goal. My goal is when we talk about these things, it's not always going to be this way, and honestly, sometimes, sometimes like, for example, if some of you guys are like, maybe you're too embarrassed to say something right now, you're always free to ask. Actually, you know what? I'll stop this too because we don't need recording. Stop my sharing and stop my recording.